So this question wants us to work out which of these temperatures match the melting boiling point. To help explain this one, I've drawn myself a number line. Room temperature is normally around 2022, so it's in here. And if we remember on here, what this means is once it's melted, this point here, all the way up to there, it would be in a liquid state. And then it says it vaporizes easily, so it suggests that the boiling point is near to the room temperature point. So if you use that information, A would be a liquid, a gas at both points. B, this is too low, so that would also be a gas at 22. C would work, so I'm going to have C on there, and D would be too high. That boiling point is way too high for this substance. So the option is going to be C. Okay, here we've got to explain why graphene is a good conductor. Let's remind ourselves, in graphene, I'm going to pick on one of these carbon atoms here. This is forming 1, 2, 3 bonds. Carbon would normally want to make 4, so let's write these points down. Okay, so carbon wants to make 4 bonds. In this structure here, in graphene, it forms 3 bonds. So that means there are delocalized electrons, the electrons that are free, and that means they are free to move. There's 3 marks and 1 mark for each of the bullet points in there. Okay, next question says here's a potassium chloride structure. It's got a melting point of 770, which is quite high. Explain why this is high. So remember, if it has a high melting point, then it indicates that the bonds inside here are strong. So what we need to say here is that this is an ionic lattice structure. That means there are strong forces of attraction which need a lot of energy to break. 2 marks. It's going to be the first 2 points in here. So it's ionic lattice, and there are strong forces of attraction between the ions. Okay, this is a 6 marker. It's quite a different format to what we've seen normally. We've got lots of different representations of the molecule for methane. It says describe what information could you get from each and any limitations with these representations. So first bullet point is that they all show methane. A is good because it shows you that there is carbon and hydrogen, and it shows you the ratio is 1 to 4. A doesn't show you limitations. A doesn't show you the bonds that are being formed, and it also doesn't show you the shape of the molecule. B, in B here we can see we've got the covalent bonds are being shown. You've got those shared pair of electrons, and you can see they are single covalent bonds that are being produced. This is a 2D diagram, so B's limitation is that it doesn't show you the 3D structure, 3D shape of the molecule. C, okay, this is C. Again, we've got the bonds being shown. So C here is showing you that they're single covalent bonds, but again, it doesn't show me how the 3D structure is going to work for this. It's just a flat diagram. D does show me the structure, and it shows me the bonds that are being formed. So D does show the covalent bonds. It does show me that 3D shape, but it shows me the atoms are being connected by sticks. We know that is not right. It's just a representation. So that'd be a limit of diagram D. Come back up here to E. E, we've got the shape, which is brilliant. We've got relative sizes, so the carbon in the middle here is much larger than the hydrogens. What I can't see here is the bonds that are being formed. So E shows me 3D arrangement. It shows me the size of atoms, but it doesn't show me the bonds in the structure. If you count those up, there's 15 bullet points. So what I've done here is create a table with the ranges in. So if you've got over 14, give yourself 6, and so on and so on and so on as you go down here to get a total for that particular question.